The aurora borealis, or northern lights, is one of the most beautiful, natural occurring phenomena known to man. These shimmering currents of light, which are normally seen near the Arctic Circle, have intrigued and inspired observers for thousands of years. Until the late 19th century, many still believed that the northern lights were driven by supernatural means, rather than by natural means. Although these old beliefs are intriguing, we now know that the auroras are actually caused by energized particles colliding with the Earth's magnetosphere. Until recently, the auroras had little direct impact on life here on Earth. But with almost every person on the planet now relying on satellites and electricity as part of their daily lives, the need to understand auroral activity has increased. This is because those same particles that collide with the magnetosphere to create the northern lights can also severely damage important satellites and cause outages in electrical power grids around the world. In an effort to better understand these events, NASA is using innovative technologies to learn more about the northern lights and how they affect us here on Earth. I spoke with NASA Goddard's Dr. Sten Odenwald here at the Andøya Rocket Range in Andenes, Norway, to find out more.
It's a very complicated process that leads to an aurora. Once you see it, the whole process is sort of hidden from view. We understand a little bit about how the particles get from the outer parts of the magnetic field of the Earth and into the atmosphere, but we don't see the details, how the particles go from one kind of a system into another, how they get boosted in energy. Even at this late stage, we don't exactly know what the particles are that produce the aurora. Tracking them from where they're produced and where they're energized all the way down to the atmosphere is still something of a mystery, and that's why we have satellite and rocket experiments that are trying to fill in those missing pieces of the puzzle.
To understand why it is important to study the northern lights, we must first understand how they work. The sun is constantly emitting streams of electrically charged particles in all directions.
This stream of charged particles is called the solar wind. Since the sun is 93 million miles away, it takes about 3 days for the particles to reach Earth. As the solar winds flow by the Earth, it causes a disturbance in the Earth's magnetosphere. This disturbance energizes currents of particles which are steered by magnetic forces towards the Earth's poles. These energized particles collide with oxygen and nitrogen atoms in our atmosphere, which produce the colorful light that we see in the aurora. Although beautiful to watch, these currents of particles are actually a form of electricity, which can generate up to 800 gigawatts of electrical power. This electrical energy flowing in the upper atmosphere can cause currents to flow in the ground, producing disruptions in communication, electrical outages, and fuel leaks. The high-energy particles flowing in space that often accompany these storms can also hit satellites, damaging their sensitive electronics and creating false commands. This can wreak havoc on television, pager, and other communication services here on Earth. NASA researchers hope to find new ways to predict not only when these storms will hit Earth, but also hope to find ways to reduce their destructive effects when they do.
What are some of the tools you use to study the northern lights?
We have satellites that seem to be able to look at everything that goes on with a solar storm and the production of aurora, literally from cradle to grave. We have satellites that watch the solar surface for the big leaps of matter and energy. We've got satellites that look at the wind in between the planets to watch what that's doing. We also have satellites that are in tighter orbits to the Earth so that they can look at the poles of the Earth and see the aurora happen. They can also measure electric fields in space and magnetic fields in space. So they can also see the invisible flows of particles around the Earth. And then finally, we have rockets that go up into the aurora from the bottom at the same time that the satellites are passing overhead. So we can kind of see the physics in between, flows of particles inwards, and the rockets see the electrical fields that are set up by these things. And we get this complete picture from rockets and satellite observations.
So why is Norway such a popular place to study the northern lights?
It turns out that Norway is in a place that's very favorably located to actually see the aurora directly overhead. So you can launch the rockets directly up very quickly to get into the aurora at the time that they're changing.
Dr. Odenwald, how do you think NASA research is helping us better understand the aurora and its impact on Earth?
Well, NASA's invested an awful lot of time and effort into providing scientists with the technology and equipment they need to really make powerful and insightful discoveries about how aurora work. And that feeds into our knowledge of the environment that we live in space and how that affects human technology, our billions of dollars of satellites that we have there, the health of astronauts because of the energetic particles. It all works together, and if we can deeply understand space weather effects with the help of NASA technology, it's going to be much easier for us to operate in space, and that's the direction that we want to go as a civilization.